Hi my dear students, welcome back to our YouTube channel ADC Maths. So this is the problem number 4 under the one-dimensional wave equation with zero initial velocity. The fourth problem. So what is the problem actually? Let us see that. The string is tightly stretched and its ends are fastened at 2 points x equal to 0 and x equal to L. The midpoint of the string. So this is the 2 points x equal to 0 and x is equal to L. And the midpoint of the string is displaced transversely through a small distance b. So this is some distance b transversely from the bottom of the string, and the string is released from the rest. So what's mean that? So the string is, now this is the position of the string. So we can take the string to the height of b from the midpoint. What's the midpoint here? It is L by 2 comma 0. So this side is 0 comma 0 and this side is L comma 0. So this is the midpoint. So what's the midpoint here? L by 2 by the height b. And this is the left hand side, so this is the O, this is the A. Okay. Now my string is like this, then I released from this position. So during the subsequent motion, what will be the displacement function of the string? So that is the question here. So once I repeat this, a string is tightly stretched and its ends x equal to 0 and x equal to L. The midpoint of the string is displaced transversely through a small distance b, and the string is released from rest in that position. So my string is like this way. So initially, what is the displacement function? So this is the first idea, because in this question number 4, problem number 4, the initial displacement function is not given, but we have to find out the initial displacement function by using this midpoint category, midpoint concept. How do we know in geometry? When we join the 2 points, we get a straight line. So what is the equation of the line joining of 2 points x1 y1 and x2 y2? The 2-point formula says that it is y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So by using the 2-point formula for the first of OM, equation OM, we get the initial displacement. For the second of MA, we get the another displacement function for the second half. So for the first half, 0 to L by 2. For the first half, 0 less than x less than L by 2, what will be the displacement function? For the second half, that's L by 2 to L. From L by 2 to L, what will be the displacement function? So that's the first question. Yeah. So after getting the initial displacement function, obviously once we have the non-zero initial displacement function, then automatically this comes under velocity 0 case. Is that right? Now let's find out. So first we have to find the initial. First we have to find the initial displacement function. Initial displacement function of the string. How? So when I take the equation OM, what's the equation of OM for the first half? So 0 less than x less than L by 2. So what is the O? O is the origin 0 comma 0. So this is, I can consider this is x1 comma y1. And what about the M? M is the midpoint. That is L by 2 comma b. So this is equal to x2 comma y2. So by using the 2-point formula, then we get the initial displacement function. So y minus y1 0 by y2 minus y1, b minus 0 is equal to x minus x1 0 by x2 minus x1, L by 2 minus 0. So let us simplify this. We get b equal to, I think this is 2x by L, this b get cross multiplied. So we get this 2b by L into x. So this is the initial displacement function for the first half of the string. What about the second one? The second one, the equation from MB, from MA, for the second half L by 2 less than x less than L. So what is the m? Yeah, m is here L by 2 comma b. So this time I named as it is x1 comma y1, and for the a it is L comma 0. Is it L comma 0 a? So this is my x2 comma y2. Now by using the same 2-point formula, y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. So what we write, y minus y1, what's the y1? B by y2 minus y1, 0 minus b is equal to x minus x1. What's x1? L by 2 by x2 minus x1, so L minus L by 2. Is right, sir? So by that way we get y minus b by minus b is equal to, what is this? L minus L by 2 is L by 2, make the reciprocal. It is 2 by L into x minus L by 2. Then we can simplify this, we get the answer y is equal to 2b by L into L minus x. So this is the initial displacement function for the second half. So this is the way to get the initial displacement function once the midpoint of the string taken to the height of b, then released from that position, then that is the initial displacement function. So now what is the initial displacement function? Y of x comma 0 is equal to 2b by L into x in 0 less than x less than L by 2, and 2b by L into L minus x in L by 2 less than x less than L. So this is now initial displacement function. Now once we have the initial displacement function, the velocity is 0. Right, sir? Already we have made a separate videos to determine the 0 initial velocity type. Please just go and watch the problem 1, 2 and 3, the similar cases. Yeah. Now, what are the boundary conditions for this case? The boundary conditions for this problem is, the boundary conditions for first one, when x equal to 0, there is no displacement for all t greater than or equal to 0. The second boundary condition, y of L comma t, because these two extreme points are fixed, so no displacement. And the third one is initial velocity is 0. Initial velocity is 0. Initial velocity is 0. That means that dou y by dou t at t equal to 0 is equal to 0 in between the 2 points. The fourth one, the initial displacement function, now we have to get, that is y of x comma 0 is equal to 2b by L x in 0 less than x less than L by 2. And what about the other one? The other one is 2b by L into L minus x in L by 2 less than x less than L. Right? It's clear? Right? Now, as we already know that what is the correct solution? The correct solution of the one-dimensional wave equation is y of x comma t is equal to a cos px plus b sin px into c cos pat plus d sin pat. Isn't it? Alright? So once we apply the first boundary condition, we get a equal to 0. We apply the second boundary condition, we get p equal to n pi by L. We apply the third one, we get d equal to 0. So this becomes a and d becomes 0. Please kindly watch the previous videos, problem number 1, 2, 3. There we derive the same thing. Now, after getting the a equal to 0, p equal to n pi by L by using condition number 2, then the third condition, d equal to 0, we may find the most general solution. That is the required displacement function is y of x comma t is equal to sigma n equal to 1 to infinity bn sin. What about the p value? P equal to n pi by L. So we get is sin n pi by L into x. And what about the next one? Cos, because c and b combined together as bn, right? Cos n pi at by L. So this is my required most general solution superstar equation. Now, I would like to apply the fourth boundary condition, that is the initial displacement function in this star equation. So let us apply the, finally using the condition number 4, in the star equation by putting t equal to 0, what we will get, I think so we will get, by putting n equal to 0, this t equal to 0, sigma n equal to 1 to infinity, bn sin n pi x by l. What about cos 0? Ma? Cos 0 is 1, so this is 0. Now this is equal to the given, the initial displacement function. I can name this by f of x. So it is 2b by l into x in 0 less than l by 2, and 2b by l into l minus x in l by 2 less than x less than 2. Right? So this is the fourth boundary condition. So after applying the fourth boundary condition, I need to determine the bn value. That's right. So the left hand side looks like the half range sine series. So my aim is to use the half range sine series concept here. So what we know, as we know that, so to find the bn, value, capital Bn value, so how to get the capital Bn value? To expand the left hand side as the half range sine series, we get capital Bn and small bn is equal to. Why they are equal? Because as you see that, to expand the left hand side, f of x as sine series expansion, as sine series in the interval 0 less than x less than l, then the left hand side becomes sigma n is equal to 1 to infinity capital Bn sin n pi x by l. Now I am going to express the f of x as half range sine series, sigma n equal to 1 to infinity small bn sin n pi x by l. Isn't it? Right? Now what we do, we can compare it. Comparing both these sides are equaling like coefficients on both these sides. What we'll get? We get capital Bn is equal to small bn is equal to 2 by L. So what's the formula for the Bn formula? You remember? 2 by L integral 0 to L f of x sin n pi x by L into dx. Now what is my f of x? I think so this is the f of x. We can divide this into two separate integrals. Let us divide this into two separate integrals, so that it is 2 by L integral 0 to L by 2 2b by L into x into sin n pi x by L dx plus integral L by 2 to L 2b by L into L minus x into sin n pi x by L into dx. I think so from this I found that 2b by L is a common, so can I take the 2b by L outside? So what I am getting that? I am getting the 2b by L outside. So capital Bn is equal to 2 by L into 2b by L outside, right? So what's the balance? The balance is only x alone. So can we use the Bernoulli formula for the first integral? Take it as u is equal to x. The same thing, we apply the Bernoulli formula for the second interval. We take it as u is equal to L minus x. U is equal to L minus x. So can we apply the Bernoulli formula now? Let us see that. Into, when you apply the Bernoulli formula for the first integral, x sin n pi x by L integration is minus cos n pi x by L by n pi by L. That's right. Minus, when I differentiate this x, we get 1. When we integrate this one, we get minus sin n pi x by L by n pi by L to the whole square. So hereafter we cannot proceed because 1 becomes 0. So to close the integral part, x equal to 0 to x is equal to L by 2. What about the second term? The second term is, the second integral part is L by 2 to L. We have already considered 2b by L as outside. So plus, this time u is equal to L minus x. So L minus x, again sin n pi x by L. Integration is minus cos n pi x by L by n pi by L minus, formula minus, L minus x differential is minus 1 and minus sin n pi x by L by n pi by L to the whole square. Is right? Now for this integral, the limits are x equal to L by 2 to L because this is for the second half. Understand? Right? Now can we use the limits? Can we apply the limits for this step? What we will get? So the first of all, this is 4b by L square, right? Now can we use x is equal to L by 2 here? we get is L by 2. I think so. This minus sign is there. So minus this is reciprocal L by n pi. Substitute x equal to L by 2, we get cos n pi by 2 because after cancellation of L, x equal to L by 2, right? Here minus or minus plus, the reciprocal is L by n pi to the whole square. And by putting x equal to L by 2, we get this sine of n pi by 2. Isn't this right? Now putting x equal to 0, because the lower limit is 0, 0 and anything 0, here sine 0 is 0. So the lower limit value is completely 0. Now let us move on to this side, the second integral. Here x equal to L is the upper limit. When I substitute x equal to L here, L minus L 0, 0 and anything 0. By putting x equal to L, sine n pi, because after cancellation of L, sine n pi 0 is 0. So this upper limit is completely 0. So upper limit is completely 0. So this is the first term, right? This is first term. Now second term, upper limit is 0 minus of the lower limit. What's the lower limit now? X equal to L by 2. So L minus L by 2 is L by 2. And this minus sign is there. So minus the reciprocal L by n pi. By putting x equal to L by 2, we get this cos n pi by 2. Right? Then minus or minus plus, plus and minus is minus L by n pi to the whole square into sine n pi by 2. Got it? So this is the second. Okay. Now this is the minus or minus becomes plus. This is minus or minus becomes plus. So I found that this minus L by 2, L by n pi cos n pi by 2, this becomes plus L by 2, L by n pi cos n pi by 2 will cancel. So the rest is L by n pi whole square sin n pi by 2. This is also minus or minus becomes plus L by n pi whole square sin n pi by 2. So twice the time. So it's going to 4b by L square. Twice the time L squared by n squared pi squared sin n pi by 2. So after cancelling the L square, we found that capital Bn value is, what's capital Bn value? Capital Bn value is equal to, small bn value is equal to 4 into 2, 8b by n squared pi squared sin of n pi by 2. So this is my capital Bn value. So let's substitute this capital Bn value in the most general solution. So using capital Bn value in the most general solution, the star equation, we have or we obtain that. So what we obtain? We obtain the required displacement function of the string. So y of x comma t is equal to sigma n equal to 1 to infinity 8b by n squared pi squared into sin n pi by 2 into sin of n pi x by n into cos of n pi at by n into cos of n pi at by n. So is the required displacement function. Is the required displacement function. Is the required displacement function. That's it. So I hope you may understand this type. This is the fourth model in the zero initial velocity type. Thank you for watching our YouTube channel. Please kindly subscribe our channel as well as go and see the problem number 1, 2, 3 under the zero initial velocity type. Thank you. Take care. Bye.